So our final session today will focus on decisions for material handling equipment. This will include selection, design, control, and operation, as well as maintenance. Our speaker will address belt, drag, and screw conveyors, bucket elevators, diverters, spouts, transitions, gates, and distributors. Material handling is the bailiwick of Dr. Alok Singh. Dr. Singh is a native of India, where he received agricultural technology degrees from 2 universities before receiving his PhD in biological engineering from Mississippi State University. Dr. Singh joined WL Portland Systems, a design-build company headquartered in Pittsburgh, Pennsylvania, in 2012. For the prior 4 years, he worked for ASI Industrial, formerly Agri-Systems, in the engineering and construction of grain elevators, feed mills, biorefineries, and other projects that address material storage and handling. As a proposal engineer with WL Portland Systems, he creates custom system solutions and oversees the full life cycle of proposal generations. He manages and directs the proposal development, including scope of work, conceptual design, cost estimates, and proposal preparation. All this is coordinated with his colleagues in sales, engineering, and human resources in an effort to ensure the best solution for the client. Please welcome Dr. Alok Singh.
Thank you, Eric. Again, I'm Alok Singh with WL Portland, based out of Pittsburgh, Pennsylvania, a design-build company. I'm the last one before the drinking beer session. I'll try to make it quick, skip a lot of basics. My presentation has, I think, a lot of contents in it, so I'm not going to go over each and every detail of it. And my understanding is a copy of my presentation will be available online for you guys to take or make a reference. So with that, and also I'd like to thank NGFA, Grain Journal, and Elevator Design Conference to give me opportunity to talk before you guys. I'm honored. Thank you. Like Eric said, my presentation is on material handling equipment, design, selection, operation control, maintenance, and most importantly, new practices in the industry. They are not new practices, but getting popular practices in the industry. So, with the history of grain elevator, we have moved and transformed from country elevator to terminal elevator, where a lot of operations are for import-export facilities serviced by truck, rail, barges. We have moved and moving from traditional to modern grain elevator, where all the equipments are inside, dust and weather tight. Elevators used to be carrying single material. Nowadays, elevators are carrying multiple materials, and that needs specific design based on material characteristics. Equipments in grain elevator: drag, chain conveyors, bucket elevators, belt conveyors, screw conveyors, feeder screw, distributors, slide gates, spouts, and transition. I think these covers a lot of elements in grain elevator. Again, my presentation will talk primarily about new practices. As a design build company, or on behalf of vendors, on the right side of the slide, I have listed some information we would like to see upfront in order to select and properly design your equipment. That would be material type or types, bulk densities, abrasiveness, angle of repose, moisture content, particle size and distribution, temperatures, capacity, dimensions and layout, whether you are going horizontal or vertical or both of them, number of inlets, number of outlets, loading, how you are loading your equipment, whether it's control fed, choke fed, or the equipment is starting under load. First on my list are chain or drag conveyors. They can be used for dry and wet material, non-abrasive material. They're pretty good for short distance, efficient and economical for a distance less. These numbers are not hard and fast number. They can go plus minus 30 feet or not, depending on capacity and material. Again, drag conveyors, if you need better loading, they work better than belt, and they serve multiple discharges, whereas in belt, it's hard to have multiple discharges. Some advantages and disadvantages, again, it can vary. It can handle various types of loading. Drags can deal high moisture, smaller footprints than belt conveyor. On the disadvantage side, it's limited on capacity and length. When you go more than 150 feet or higher capacity, the design requires extensive materials to be used or heavier components like chain and flights, etc. They are limited on inclination. You don't want to really incline your drag conveyor more than 12 or 15 degree. Cross-contamination on multiple discharges can be issues, and of course possible carryover could be a possibility. Types of drags, all those flat bottom, round bottom, and high flights. And all these are based on what kind of material you are conveying and what kind of layout you have to convey the distance. The last couple of lines, I thought I should mention that the horsepower requirement and cost increases for the same size drag when you go from flat to round to high flight or L path or S path conveyor. Capacity for a standard size conveyor goes down when you go from flat to round to high flight. I've shown a table at a certain speed. There's a drastic difference from when you go from flat to round to L path. Drags are best used when they are run under 150 feet per minute speed. It reduces chain wear and of course will reduce maintenance cost. Single drags can do 25,000 bushel an hour, and like I said, higher capacity drags can be built using double chain. That will, of course, increase your cost and horsepower requirement. Instrument used on drag conveyors are slack chain to detect slack, plug switch to detect any choke, motion sensor, dual point sensing motion sensor. Periodic maintenance should be done in order to make your drag go longer, like check chain tension, maintain drive oil level, and that's pretty common for any kind of equipment. Check unusual noise, lubricate bearing, and it's not a bad idea to run your drag conveyor periodically empty for a few minutes just to check if you have any unusual vibration noise or any kind of loose fasteners. New practices. Again, they are not new practices, but getting popular practices. Some of the vendors are making a better chain return system where the chain returns on the top with less maintenance or very easily than the standard roller chain assembly. This particular vendor is using a high wear UHMW material instead of standard UHMW. Now this elongate the life of drag conveyor or that system for a high capacity or 24/7 used drag conveyors. The next on this slide has a 24/40 drag conveyor, kind of unusual, where 40 is the height of the conveyor. Normally drag conveyors are wider than taller, but this one is a taller conveyor, can work well in a narrow pit, so you might save a lot of earthwork, concrete cost in installation. They're used for receiving application on high capacity. Again, it works well with narrow pit. It can go high incline up to 60 degree in divided pan. They're calling this a divided pan conveyor, where you have a short distance where you can go 60-degree inclination and from the pit to the boot of the bucket elevator to attain that kind of height. As picture shows, this is a low-profile drag. If your requirement is very low, like up to 10,000 bushel an hour, it's not low, but these days it's getting higher, so I'm saying low requirement. These kind of drag can be useful if you have a problem of groundwater or access in that area. As the picture shows here, you don't need huge pit to install these conveyor. Again, it saves a lot on concrete and earthwork. Easy installation. They can also be used as an option to a bin load-out system. Again, picture tells a lot. This particular vendor is doing double intake on these conveyor from a semi-trailer. This particular double simultaneous intake discharges onto one conveyor. So basically your unloading time is quick. On the parts of a drag conveyor, this bolt and go chain is getting new in practice because these flights are not welded on the chain. It's bolted to the chain. What it does is when you have a problem, you are not really extending the maintenance time. It's quick. You stop the conveyor, unbolt, replace, and it's quick and easy installation or maintenance process. That can be a good one for a lot of us. Vendors are making bypass inlets, double inlets, where they're using trim gates or proportionating gate where they control the feed on each inlet in order to reduce the overloading on the downstream conveyance. If you have just single inlet, you don't have to use the trim gates. You can open completely on those gates and work full load on the conveyor. Head and tail shaft. Vendors are making split head and tail shaft. It's very easy for maintenance purposes. You just pull the shaft out without having to take the bearings out. Again, quick and easy replacement. Split sprocket. Again, these are not new practices, but again, people are using more and more these days. The split sprocket is a two-piece sprocket which fits around the shaft and easy maintenance. You don't have to really extend maintenance time on these kind of spare parts. Next in my list is bucket elevator. We all know bucket elevator. That's the only option we have if we need to elevate the grain. So no disadvantage or advantage on this. You have to use bucket elevators most of the time. Can do abrasive and non-abrasive material based on your cup selection. Industry has seen centrifugal and continuous bucket elevators. Continuous bucket elevators are not being used these days because of the low capacity or low elevation. Components on bucket elevators are belt. They are rubber, SOFR, normally static, conductive, fine, oil, moisture resistant belt. Cups are non-sparking, non-corrosive. They can be made out of polyethylene, nylon, urethane, steel. I showed a comparison where cost and abrasion resistance goes high when you go from polyethylene to nylon to urethane to steel. Pulleys are crowned, slide lagging, uses vulcanized rubber. They can be spiral wing. Head section of the bucket elevators are lined at the contact point where the grain discharges on the chute. Boots are made with a different option with self-cleaning. Bearings are externally mounted, heavy-duty pillow block bearings. Special design consideration for upside and down leg side boot assembly. On the up leg inlet side, pouring of material onto the bucket should be the primary mechanism, and you design your inlet such as the low point of your boot inlet is above the center line of the pulley, boot pulley. Whereas on the down leg inlet, scooping is the mechanism, a better mechanism to convey the material. In that case, your lower portion of the boot inlet should be below to the center line of the boot pulley. During design, capacity of leg should be based on 85 to 95% of cup fill. Horsepower should be based on 100% of cup fill. Belt speed, in order to use your bucket elevator longer, should run less than 600 feet per minute for grain application, and even smaller speed for feed, pellet, and ground grain. Cup projection can vary from 6 to 9 inches for 30 to 48 inch pulley. Cup spacing are normally 1 to 2 inches more than cup projection. Legs are manufactured or installed with the magnets, whether it's manual or self-cleaning, before or on receiving, reclaim, or pre-grinding leg in order to remove any kind of ferrous material. We are using a lot of creep drive on big legs to slowly move belts in order to maintain buckets or belts. Back stops are being used on the drives to stop reverse rotation with full load under full load without any failure. Important instruments on bucket elevators are belt misalignment, bearing temperature sensor, current meter, and motion sensor. Placement of belt misalignment sensor can be at a different location, and different vendor will recommend their own preference on installing those rub sensor or belt misalignment sensor. Maintenance should be, like I said, pretty common. Check and maintain oil level, lubricate bearings, check unusual noise, vibration, drive and bearings overheating, periodically check belt for alignment, for loose bolts, damaged cups and belt weirs, throat plates, and take-ups. New practices. A lot of emphasis has been given on design of cup. Larger capacity elevators, 60,000 bushel an hour plus grain elevators, they are working on or researching on increasing big size of buckets. The first one is 28 by 10 bucket. Single row would do 30,000 bushel an hour. Double row would do 60,000. These bigger design reduces footprint by 30%, 35%, which is not bad. They are still non-corrosive, non-sparking, heat, abrasion, and impact resistant. And with the bigger size buckets, one benefit could be you can run your legs at a slower speed. So you are not, for a 60,000 bushel an hour leg, you are not really conveying your material at high speed, which will increase your life of corn or grain, whatever. The next 24 by 8 cups, this particular vendor is researching on high efficiency bucket. They're using 5 keys to increase their efficiency with smooth interior face, wingless design where nothing protrudes out on the back of the buckets, close spacing to create a larger capacity, tapered bottom, and nesting. Now this would help in storage. With a tapered bottom, you can store a lot of buckets in a small area, and of course your shipping volume will be reduced. They're also claiming that this allows high capacity on smaller footprint, calling it jumbo buckets. On the parts, a lot of vendors are using a fanged bolt. What a fanged bolt has a teeth which gets buried into the belt to easily install or do the tightening of buckets. The fangs lock bolt in place when tightening. They are making a larger bolt head diameter to resist belt pull through during installation. So basically you are not tearing the belt out while installing. Instrumentation on legs. Our industry is seeing a lot of analog instruments rather than discrete switches, open, close. A lot of RTDs type or thermocouple type, thermistor type, bearing heat sensor or belt misalignment sensors are being used. A lot of vendors are supplying hazard monitoring system for individual leg so that you can read data, analyze data, and create a preventive maintenance plans based on that system. Some of the new things, industry is seeing a lot of dual drives on big legs. When do you use 2 motors versus 1 motor? I guess my answer would be you should look at the cost of a bigger motor and drive of the bigger motor versus a small motor. The spare parts availability or even spare motor availability. You don't want to keep a 400 horsepower spare motor in your spare room. It should be okay to have a 200 horsepower motor in your spare room. Lead time on these bigger equipments, parts of the bigger equipments are longer than smaller equipments. Usage of direct drive system. This direct drive is where the gearbox is inbuilt or is intact with the motor. It improves gear geometry, it modifies the housing, it's high efficiency because you don't have belt or chain efficiency loss or transmission loss. High efficiency means low or less horsepower requirements, less maintenance because you don't have belts or chain on it. This particular vendor makes or fits backstop on leg as their standard unit. Vendors are making better belt splicing equipment in order to handle extremely thick and wide belts, and it does a quick installation too. Next on my list is belt conveyors. It can be an option to drag conveyors where you have a long conveyance length. If you are looking at more than 300 feet of grain conveyance, it's hard to design a drag conveyor. Or, I mean, you can design a drag conveyor, but the cost could be higher, horsepower requirement could be higher. Belt can serve a good purpose of conveying long distance and a higher capacity. I'm showing up 200,000. It can go even higher for conventional belt conveyor. It can do multiple inlets and single discharge easily. Multiple discharge can be possible with modification on the belt using tripper or plow mechanism. Advantages and disadvantages. Belts are not limited on capacity and length. It requires low horsepower. It has lower contamination chances, can be inclined or declined. Bad thing about belt is it's difficult to have multiple outlets outdoors. It has more moving parts, so a lot of parts are being replaced in time. Belt tracking can be difficult, and it has larger footprints than drag conveyor. It takes more space than drag conveyor. Component inside a belt conveyor are idlers, rollers, spools. Belt, same as bucket elevator, they are rubber, static, conductive, fire, oil, moisture resistant. Pulley are head pulleys are slide lagged, tails are spiral wing type. Inlets are skirted inlet where the material flows in the direction of grain flow. The inlet has a direction towards the material flow. Again, it gives the belt a better chance of increasing its life. Line inlet and discharge and bottom of the belt are normally anti-static UHMW. Best used when the speed is less than 500 feet per minute, but manufacturers are making up to 700 feet per minute for open belt or conventional belt. Motion sensor, belt alignment sensor, plug switches are most important on belt conveyor. Same thing on maintenance. You maintain oil on your gear reducer, lubricate bearings, periodically check belt for alignment on pulley, for slippage, idlers, and belt splice. Reversible belt conveyor. People are making a reversible belt conveyor where you can do loading and unloading. Unloading is easy, but the main thing is how do you load on each end. This particular vendor uses a retractable cowling on each end. So when you're loading at one end, the cowling goes down, you load, and on the other end, the cowling goes up, and you unload. It's a new design. The next one is not new, it's been used, but I thought I should mention air-supported enclosed belts. Beneficial for longer length, beneficial for high capacity. You have air to support the belt instead of idlers and rollers. Less moving parts, so less maintenance. No need for idlers, so no greasing. Less friction because you don't have idlers or rollers, that means less horsepower. And same air can be recirculated using an air cleaner. The picture shows it. As far as multiple discharge, a lot of things, triple conveyor, triple design has been followed a long time. I thought of showing this, where this belt conveyor has a lined plow, which lowers when you need a bypass inlet. This plow gets lowered and it divert the grain flow to the spouting either side and create a divert intermediate discharge. In case you need to bypass the flow, you just raise the plow up and material is flowing on the belt to the next discharge. Grain industry elevators, they also use a small amount of screw or feeder screw. They are very efficient and economical for a shorter run, low capacity, blending purposes, and efficient metering. Capacity can be ranged from 350 bushel an hour to 40,000 bushel an hour. During design, for transfer conveyor, the cross-sectional loading of a screw conveyor is around 45%. On reclaim or feeder screws, that percentage is 67%. And for distribution conveyor on load out, it can be even lower in 35 to 40% range. It can go high incline, although the capacity decreases rapidly as inclination goes up. We recommend putting hanger bearing every 10 to 12 feet of run. We recommend using helicoid screws if the screw conveyor is less than 16 inch of diameter. Sectional screw for larger diameter screws. Varying flight pitch for feeder screw to evenly regulate the flow underneath the grain bin or grain silo. Screws are best used when the speed is less than 120 revolution per minute. Plug switch, motion sensor, and bearing sensor are most important instruments on screw conveyor. Same thing on maintenance. It requires lower maintenance than other conveying equipment. Periodically check screw flights for damage, check for loose, worn, damaged coupling, bolts, and hanger bearings. Replace those hanger bearings when you have a damage more than 1/8 of an inch. Check for bolt hole elongation and wear on shaft. Maintain oil level, lubricate bearings. Immediately check unusual noise, and that's same for every equipment, every conveying equipment. I don't have anything new practices on screw conveyor, but I thought I should mention this on bin sweep. Vendors are making zero entry bin sweep. This particular equipment works for 6,000 and 10,000 bushel per hour bin unloading for up to 136 feet diameter bins. This has a spring-loaded tractor which sits down under grain pressure. So it's in lower position when grain is present above bin sweep. And as the intermediate gate or side gate on the grain bin opens up, the grain pressure goes down and the equipment starts itself to raise up. By doing that, you don't have to have a man go inside and raise or lower the equipment. So I thought I should mention that. It serves a zero entry purpose pretty well. We've been using distributor and turn heads, two types, swing set, rotary, rotating spout turn heads. Swing set type turn head or distributor requires larger footprint, they are longer than rotary. Of course, they are lower in price than rotary spouts or rotary distributors. Swing set has higher contamination possibility than rotary. Both can do multiple inlet and multiple discharge. I'm showing 3 to 30 on multiple outlet side, and single, double, triple on inlet side. These distributors are being manufactured from 6 to 38 inches of sizes, whether it's square or diameter. On free-flowing material, the spouting inside the turn head should be more than 45 degree, and for sluggish material or soft stock, that can be from 55 to 60 degree spouting angle. Liners are being used on these turn head on all three sides, inlet, outlet, and in the rotating spouts. They can be AR steel, UHMW, polyurethane, and ceramic. And in my previous slide, I showed the cost goes up when you go from AR steel to ceramic. Three types of gates, mostly used in our industry, electric, air, and manual. Electric provides high-speed operation, higher closing force. It's immune to adverse condition, cold climate, whereas air is a little cheaper than electric, but again, it freezes in cold weather. Manual gates are primarily for maintenance purposes. All the side discharges under the grain bins are manual gates. Gates can be square, rectangular, round, and design should be based on maximum allowable grain flow of less than 75 bushel an hour for grain per square inch of gate. For soft stock, that should be less than 50 cubic feet an hour per square inch. Open-close limit switches used for position indication. Proportionating gate uses analog signals, whether it should be 4 to 20 milliamp or a low voltage to signal the position of the gate to regulate the flow. Liners at all wear surfaces, and it's a good idea to keep your gates dust or accumulation free. New practices. The first one is this vendor is using a variable gate control panel where it has a dial indicator to open or close from 1 to 100. We know it's hard to do with those signals 4 to 20. It's a hit and trial method when we do startup, but this particular has a good way of doing position percentage. It's a fast acting and precise positioning system. And this vendor can easily convert their manual or electric gate into a proportionating gate. They're claiming they save time and reduces error, so this could be handy. Distributors are made, this distributor has an inverter in their control panel. What it does is operates the control motor at the distributor, and you don't need a brake motor or heater, which could save some wiring. And it's a simple design. It allows exact positioning. Distributors are being made with Ethernet connection to the plant control system. With this Ethernet connection, you can see everything online, and sometimes you can control the distributor positioning online. Smartphone applications are being manufactured or provided by the vendors to the operator to control the positions of the distributor from your smartphones. The next one I showed, this is a bigger control panel. What it does, it has a bigger screen, HMI touch screen, so you can touch and do a lot of things there with the bigger control system, bigger control panel. We are seeing a lot of requests on using encoders rather than limit switches on distributor. The encoder is again a analog instrument which reads either milliamp signals or low voltage to position the internal spouts on a circular rotation. The encoder signals the brake motor to stop at a particular position when the reading goes up or down. You don't need a lot of limit switches. In this case, you can save a lot in wiring. I don't know if you can save a lot, but you'll have a clean system. Some people are saying they are not as efficient as limit switches. Limit switches has been in use for a long time. They are easy to work with, but again, I thought I should mention that they are getting used more and more encoders. Some of the distributors are made with bigger spouts. This particular has a 48-inch diameter or square distributed spout. Can do 135,000 bushel an hour. Some distributors are being manufactured with square outlet, where you don't have to have a round to square transitioning at the discharge. Spouts and transition, they can be square, rectangular, and round. Same as the gates, the maximum allowable grain flow should be less than 75 bushel an hour per square inch. For soft stock like DDG or soybean meal, they can be less than 50 cubic feet an hour per square inch. Standard 10-gauge steel with a quarter-inch liner, that's standard, but industry is going towards thicker liners. Spout angle should be more than 35 degree for dry grain, 45 degree and more for wet grain, and 52 degree or more for soft stocks. We recommend to support your spout if they are they are longer than 10 to 25 feet. You should use a dead stop if they are longer than 25 feet in length. While preparing my presentation, I thought, I'll start with better liner means less shutdown time and less liner replacement. What I mean to say that is industry is going back and forth from ceramic and urethane. Some people are saying urethane is best, ceramic is best. I created a chart showing ceramics have a high abrasion resistance than urethane. It has a longer life than urethane. But on high capacity grain flow, ceramics are prone to cracking. They are costly than urethane. They're hard to cut and drill, where urethane is easy to cut and drill. Ceramics can be hard on flowing material. Grain degradation can be a good, in case of high capacity, can be a big possibility with ceramics, whereas urethane is pretty softer on grains. Heavy duty liners, like I said, half-inch lining is not uncommon these days. Again, on bigger size capacity, like 60,000 bushel an hour, we are seeing a lot of requests with half-inch ceramic lining. Use of ceramic is increasing in the grain industry. Use of composite lining, where you mix urethane and ceramic to create a better solution, and those better solutions are better abrasion resistant than urethane, lighter weight than ceramic, and that saves a lot on shipping or handling. Less cracking than ceramics, and the cost is in between ceramics and urethane. Some vendors are making urethane sheet with ceramic chips impregnated in it. Again, serves the same purpose as better resistance to abrasion, lasts longer than urethane, easier shipment than ceramics. Some vendors are making bolt with urethane cap. What it does is it creates a uniformity inside a urethane sheet. So your flowing material is flowing uniformly. This particular has a flat surface on the bolt head. So your grain or material is not bouncing. So again, it creates a longer life than steel. Moisture shouldn't be a big problem. In case of steel, it can corrode, but with this urethane cap bolt, it should be a longer life than steel. Urethane are more forgiving than steel, softer than steel, I meant. Liners are manufactured with the flame retardant additive. Manufacturers are putting additives on liners. They are flame retardant. They are claiming they have a longer life. They self-extinguish the flame. With the use of better formulation and need, these additives can be manipulated, again, based on the needs. Flame retardant liner on urethane and ceramic composite. Vendors are manipulating the percentage of ceramics on urethane to create a better solution based on the need. We are seeing a lot of epoxy glue uses over silicone on adhering the ceramic and steel. It creates a longer longevity for the material too. Next topic on my presentation is our industry is seeing increased or intensive automation practicing. Like a lot of people are using analog instrument instead of discrete open-close type switches. It provides better readout option. Again, when you are measuring the temperature all day long, you can do a data analysis, and based on that, you can create a preventive maintenance plan, or you can increase the equipment performance, or you can develop a better process for your solutions. These analog instruments are helpful, and they reduces manual measurements. Examples are bearing temperature and belt misalignments. Again, a lot of RTDs type, thermocouple type, thermistor type temperature elements are used to read the temperature on bearing or belt alignment instruments. We are seeing a lot of requests on continuous level sensing to reduce manual inventory instead of point level sensing. Different continuous level sensors are radar type, which is non-contacting, guided wave radar type. It's in contact. Normally, it gets in contact with material. Ultrasonic type, non-contacting, cable-based, smart bulb type. Not new, but we are seeing more and more of these. The last on this slide is a 3D scanning of bin. I think it's a good tool for any plant to have, and they are not very expensive, to look at your profile inside the grain bin, how my grain looks like inside the grain bin. Do I have a problem? These should be a good tool in order to solve a lot of problems. Use of RFID technology. As our elevators are getting larger and larger, everybody wants to save time. Everybody wants quick loading, unloading on their plant. This RFID technology can be handy. It's a RFID card given to a truck driver. When the driver pulls in a facility, he will scan his card. The plant control system will recognize him. He will go to get probed, scaled, load or unload, come back and again onto the scale in the guardhouse, and at all positions he will scan his card, and the plant control system will recognize him at every point, and once he comes back on the guardhouse, he has everything in a computer-based system. He'll get a ticket with all his information. So that will be something our industry will see more and more. You don't have to have manpower attending driver at each location. It's automatic process. It saves time and quick loading and unloading process. We are seeing a lot of vendors making data collection system. I was telling previously that based on these analog instruments, you can create or you can develop a data on bearing temperatures, motion, belt alignment. You can store, analyze, and display the data online to various channels within your organization on smartphone, tablet, iPad, or PC. This system, data collection system, can give you or send email about any alarms or reports to everybody. Can be useful tool for preventive maintenance on equipments. Vendors are making smart testing tools to verify field instruments. These tools can be useful for elevator personnel, or you can ask for a professional help from these vendors to come and visit your site and create a report on what needs to be done or what's happening in your plant. The last one is, again, same thing. You can ask for professional help on hazard monitoring system within your plant on an annual basis to check what's wrong, how are the sensors working, or how is your alarm system working, if it needs any improvement or not. So those kind of service are available these days. As we are going towards higher capacity grain elevator, one question is to be asked: do you need one large equipment versus two smaller equipment? In case, do you need one 80,000 bushel an hour bucket elevator or two 40,000 bushel an hour leg? Like, I would ask these questions: what is the cost of your equipment? Cost of structural steels to support that big equipment versus two small equipment. Cost of motor and drive, cost of wiring, etc. What's the footprint? How much space one big leg versus two small leg is taking? Do you need redundancy in your process? If you do, then you would rather go with two small equipments. Downtime. When one large equipment goes down, you're done. When you have two equipments and one leg goes down, you still have your process running at half capacity. So, and the last one is spare drive or parts availability. On these bigger equipment, you might have a longer lead time on 500 horsepower motor versus bigger bearing, bigger shaft. When you have a small 200 horsepower, you can keep one motor, one 200 horsepower in your spare room, or you have smaller spare part component. So these are the questions you need to be asking when you are deciding what do you want. What is the threshold capacity? I don't know. 40,000, 50, 60, I don't know. I guess based on these answer to these questions, we should be able to decide where do we go for one versus two. I guess summary or future of our industry, we will go to higher capacity elevator. Equipment will get bigger, heavier, stronger, extensive design, higher quality equipments, high efficiency bucket, belt, chain, liner, etc. Heavier components will not be uncommon. Big motors, gear reducer, direct drive system, heavier rear liner, composite lining, higher degree of automation. We are seeing intensive control system these days. Use of smartphone, tablet in our process control. And that should be it.